Welcome to my channel. In this video I teach you the Cannizzaro reaction and its mechanism. Cannizzaro reaction, it's a reaction in which the aldehydes which do not contain alpha hydrogen atoms are involving. Suppose I take benzaldehyde C6H5CHO. It does not contain alpha hydrogen. You all know that here. You know its structure. This is here, no hydrogen is there. This is called alpha hydrogen. It does not contain alpha hydrogen. Then we go for formaldehyde. It does not contain alpha hydrogen. So here no alpha hydrogen. It has no alpha hydrogen. In this it has no alpha hydrogen. Suppose I take an example here, acetaldehyde. Will it undergo here Cannizzaro reaction? It won't undergo Cannizzaro reaction. Why? Because it has alpha hydrogen. Suppose I replace here all the three hydrogens by chlorine atom. Assume this Cl3CHO. It is named as here trichloroacetaldehyde. Will it involve in Cannizzaro reaction? Definitely it involves in the Cannizzaro reaction because it has here alpha carbon is there, but there is no alpha hydrogen. Alpha hydrogen is absent. So it involves in the Cannizzaro reaction. Right. Now, how to carry out this Cannizzaro reaction? Suppose in this here, you assume this. I take benzaldehyde. Assume this. I take here benzaldehyde C6H5CHO. To this, I add here concentrated sodium hydroxide 50%. Concentration 50%. When concentrated sodium hydroxide 50% is added to benzaldehyde, what will happen? What will happen? Benzaldehyde molecules, that means the reaction is happening in between the two benzaldehyde molecules. One molecule is undergoing oxidation, another one is undergoing reduction. I write the reaction of this. You see, one is benzaldehyde C6H5CHO plus C6H5CHO in the presence of concentrated NaOH 50%. What will happen? One molecule, it is benzaldehyde. So one molecule of benzaldehyde is undergoing oxidation, another molecule of benzaldehyde is undergoing reduction. Here both the benzaldehydes are same type. So you can have either this is undergoing oxidation or this is undergoing oxidation. You assume this, it is undergoing reduction. This is undergoing oxidation. It undergoes oxidation. It undergoes reduction. It undergoes oxidation. When it undergoes reduction, what happens? This aldehyde functional group. You all know that here, when an aldehyde functional group is oxidized, what happens? Addition of oxygen takes place and it is becoming acid, carboxylic acid. When the same aldehyde functional group is undergoing reduction, what happens? Two hydrogen atom added, one hydrogen atom here CH2OH, then it is becoming primary alcohol. So one is undergoing oxidation, another one is undergoing reduction. Which one undergoes reduction? That aldehyde functional group is becoming a primary alcohol. So here one of the product CH2OH. Already we have C6H5, that is becoming C6H5 plus. It undergoes oxidation. Oxidation means this aldehyde functional group is undergoing oxidation, that it becomes here COOH. Already we have C6H5. But this reaction is carried out in the presence of sodium hydroxide. So this acid is becoming its salt, sodium. This one is named as here benzyl alcohol. This is sodium benzoate. It is sodium benzoate. Suppose in the exam you assume that here they ask when benzaldehyde is involved in Cannizzaro reaction, what is the reducing agent and what is the oxidizing agent? Both the molecules are same. Here which one is undergoing oxidation? That is called reducing agent. Which one is undergoing reduction? That is called as a oxidizing. Which one is undergoing oxidation? That is called reducing agent. Which one undergoes reduction? That is called as a oxidizing agent. So in Cannizzaro reaction, Cannizzaro reaction, two types. Here how many types are there? Two types. One is called simple Cannizzaro. Simple Cannizzaro. What is called simple Cannizzaro? Simple Cannizzaro means, you all know, both the aldehyde molecules involving in that reaction do not contain alpha hydrogen. Both the molecules are same type. That is called simple. Another one is called here craft. The simple Cannizzaro reaction is otherwise called here disproportionation reaction. Disproportionation reaction, or it is otherwise called here self oxidation and reduction reaction. Why it is called self oxidation and reduction? Self oxidation means one is undergoing oxidation with the help of oxidizing agent, that is the same type. Suppose I take in simple, right, I take the reaction benzaldehyde. So C6H5CHO plus C6H5CHO here added with sodium hydroxide 50%. What happened? One molecule is undergoing oxidation. If it undergoes oxidation, CHO is becoming COOH. Oxidation. Plus one is undergoing reduction. If it undergoes reduction, that aldehyde group is converted to primary alkyl group, CH2OH. It is C6H5 here. But here acid is there, in the presence of base, that it is becoming its salt. It is becoming its salt. Then instead of this it comes sodium. That is called sodium benzoate. It is named here benzyl alcohol. Suppose I put some questions regarding this. In that Cannizzaro reaction of benzaldehyde, what is the reducing agent? You write benzaldehyde. What is the oxidizing agent? You write here benzaldehyde. The benzaldehyde which is acting as oxidizing agent will undergo reduction, that is becoming alcohol. The benzaldehyde which is acting as reducing agent will undergo oxidation. Oxidizing agent, it will undergo a reduction, right? Now here, what is the reducing agent in this reaction? Benzaldehyde. What is the oxidizing agent in this reaction? Benzaldehyde. That's all about here, simple. It is always called disproportionation. What is called disproportionation reaction? It is a type of reaction. Disproportionation reaction, it's a type of reaction in which one is undergoing reduction, another one is undergoing oxidation, right? That is called simple Cannizzaro reaction. Then I come to here craft Cannizzaro reaction. What is called craft? Here also two molecules of aldehydes are involved which do not contain carbon, but they are different. Suppose you see, I take a beaker, in this benzaldehyde is taken and formaldehyde is taken. To this I add sodium hydroxide which is 50%. What happens to this? So reaction happens in between these two molecules. So benzaldehyde plus formaldehyde, sodium hydroxide 50%. One is undergoing reduction, another one is undergoing oxidation. You see which one will undergo reduction, which one will undergo oxidation. Here you see formaldehyde is more reactive than benzaldehyde. The aldehyde which is more reactive will undergo oxidation. It will undergo oxidation. Compared to this, it has more number of, it is less reactive. The less reactive aldehyde is undergoing reduction. Or one more way to keep it in memory, the aldehyde which contains less number of carbon is undergoing oxidation. The aldehyde which contains more number of carbon is undergoing reduction. When it is reduced, the aldehyde functional group is becoming primary alcohol. Plus here, then aldehyde which is undergoing oxidation is becoming acid. It is formic acid. But its sodium salt is called formate. What formate? Sodium formate. This is benzyl alcohol. regarding this crashed Cannizzaro reaction. You see what questions I ask. In the crashed Cannizzaro reaction of benzaldehyde and formaldehyde, which is a reducing agent, which undergoes oxidation, this is called reducing agent. Reducing agent. Which is oxidizing agent? Which one is undergoing reduction? That is called oxidizing agent. So it is oxidizing agent. It is oxidizing agent. That's all about this crashed and simple Cannizzaro reaction. Now we will move on to the reaction mechanism of simple Cannizzaro reaction. Simple Cannizzaro reaction mechanism. I write the reaction of this in which benzaldehyde is involving. Sodium hydroxide concentrated 50%. One is undergoing oxidation. Which one undergoes oxidation? That is becoming acid. Which one undergoes reduction? That is becoming alcohol. It is primary alcohol, benzyl alcohol, plus C6H5, COOH. Here sodium is there. Sodium. It is named as sodium benzoate. You all know. This is benzyl alcohol. Now I show the mechanism of this. What is called mechanism? It says in a chemical reaction how the reactants are converted to product. In how many steps the reactants are converted to product. That is called mechanism. Here the simple Cannizzaro reaction or a crashed Cannizzaro reaction, both are taking place in 3 steps. 3 steps. What is the first step in this? It is nucleophilic attack. What is our nucleophile in this case? OH minus supplied by sodium hydroxide. Nucleophilic attack. This attack is happening on carbonyl carbon. What is called carbonyl carbon? This is this carbon, carbonyl carbon of benzaldehyde. Benzaldehyde. I write here benzaldehyde C6H5C. How I write here, this is double bond O, single bond H. This is benzaldehyde. What attacks? OH minus attacks. Negative attacks this. This carbon is electron deficient. When this attacks here, this double bond breaks and it comes out on this. Because attacking means this is making bond with this. If it makes bond with this carbon, the number of bonds around carbon will be 5. But carbon maintains only 4 valency, not 5. So one of this double bond, that is pi bond, it breaks and the electrons are taken up by this. That it becomes C6H5C. It is H, single bond O minus, this one adds, it is OH. You see here, when oxygen is surrounded by single bond, it carries negative sign. When oxygen is surrounded by double bond, it does not carry any sign. This is here hydroxy alkoxide. No need of name. In the second step, what is our second step in this? You see, this is from this here hydride ion transfer. So H minus is called hydride ion transfer. That means it moves from this hydride ion transfer to another benzaldehyde molecule. Hydride ion transfer from this to another benzaldehyde molecule. Another benzaldehyde molecule. So I write here, it is C6H5C. It is H, single bond O minus with OH plus another benzaldehyde, right? Another benzaldehyde C6H5C. You see here, I write here, it is another benzaldehyde, double bond O. It is single bond H. You can write single bond H like this. Another benzaldehyde. So from this here H minus ion goes. This H cannot leave this ion as H minus, because it is connected to oxygen. It will lose electron and it can move as only H plus. But this hydrogen can leave this ion as H minus. It can leave this as H minus. Minus is going to attack this carbonyl group of another benzaldehyde. When minus is attacking, it attacks on the carbon. When the carbonyl carbon gets attacked from nucleophile, one of the double bond breaks here. You see what I am getting? C6H5C. You see here it leaves us H minus, means it takes its 2 electrons from the bond and it leaves. When both electrons are taken up, carbon is surrounded only by 1, 2, 3. So here this must come here as double bond. So it is double bond O, single bond OH plus this minus adds to this, that it is becoming C6, it is H5C, single bond H, here it is single bond H, here it breaks and it comes O minus. It is becoming O minus. Now in that reaction, you see, in this reaction we showed the formation of benzyl alcohol, but it is benzoxide ion. You convert this to benzyl alcohol. So from this to this, what happened? H plus ion transfer. Now the third point I write here, H plus transfer. In the book it is given acid base reaction. H plus ion transfers from benzoic acid to benzoxide ion to benzoxide ion. You see, I take C6H5C, single bond OH, double bond O plus, I write this C6H5CHO minus. So here H plus ion transfer, it can leave this as H plus. It can leave this. So here this and this. Now it is becoming C6H5COO minus. I read this C6H5C double bond, single bond O minus plus this one oxygen takes this and it is becoming C6H5CH2OH. This is benzyl alcohol, this one is. In this solution, sodium ion is there that combines with this and it is becoming sodium benzoate. It is benzyl alcohol. So it is sodium benzoate, it is called benzyl alcohol. Thanks for watching my video.